Kia ora koutou katoa, it's Mrs. Goodson here, and this video is about energy change calculations using mole ratios. It is video 18 for Chemistry 2.4 Bonding and Structure, and it's all about how using mole ratios to calculate the amount of energy released or the amount of energy absorbed in a chemical reaction. So, in a chemical reaction that is balanced, a chemical equation, the coefficients is the number at the front of the difference. So this has got number 1 implied. So these are the coefficients. These coefficients in a balanced equation give the relative amounts in moles of reactants and products. So what this equation is saying, if we were talking in terms of particles, then there are 2 molecules of sodium dioxide, there is 1 molecule of oxygen gas, and there are 2 molecules of sulfur trioxide. All right, so because molecules are really, really small, we talk about moles of molecules. So we've got 2 moles of sulfur dioxide reacts with 1 mole of oxygen gas to form 2 moles of sulfur trioxide. The mole ratio is the ratio amounts of the entities in a chemical reaction. So in this reaction, we've got 2 moles of hydrogen molecules react with 1 mole of oxygen molecules to make 2 moles of water molecules. So the mole ratio is 2, 1, 2. So that means for every 2 moles of hydrogen gas, we only need 1 mole of oxygen gas to react, and that forms 2 moles of water molecules. Thermochemical equations are equations when the change in enthalpy or the change in heat is given. For example, when 1 mole of sodium hydroxide dissolves in water, 20.3 kilojoules of energy is released. So the equation for that is we've got 1 mole, so remember there's a 1 implied there, 1 mole of sodium hydroxide solid reacts and dissolves in water. There's so much water, we just leave the water out of dissolving equations. So we've got 1 mole of sodium ions and 1 mole of hydroxide ions. And the AQ means that they're dissolved in water. And that releases 20.2 kilojoules for every mole of that reaction happening. So the change in enthalpy, little r, means for this reaction is minus 20.2 kilojoules per mole. So enthalpy, just a reminder, is given in kilojoules per mole, or kgmol minus 1. That means kilojoules per mole, where the mole refers to the amounts indicated in the equation by the coefficients. So we can use the coefficients to give us the mole ratio, and then that relates to how much energy is released for that particular balanced chemical equation. So this equation tells us that when 2 moles of sodium dioxide react with 1 mole of oxygen gas, 2 moles, there's a 2 there, 2 moles of sodium trioxide are formed, and this bit here tells us, the minus tells us that the energy is released. So we can, just so we know, we could either put minus 188, or we could say that 188 kilojoules of energy are released. So the equation tells you the number of moles of reactants and the number of moles of products. So for Chemistry 2.4, you might be required to calculate the heat energy released, or as a symbol, delta RH, when a given amount in moles of reactant is used or a product formed. You might be asked to calculate the heat energy released when a certain mass of reactant is used or product is formed. So mass is always going to be in grams, okay? Or you might be asked to calculate the mass required to release a certain amount of energy. Or you might be asked to compare the energy release for 2 different equations. Okay, we're going to go through an example here. We're going to use this chemical equation for sodium dioxide plus oxygen is going to make sodium trioxide and it releases 188 kilojoules per mole. So the question is, what is the amount of heat energy released when 1 mole of sodium dioxide reacts? So we go and look at our equation, and sodium dioxide is this one here because it's a reactant. So in the equation, there's 2 moles of this react. So the question is asking, well, how much will it be when only 1 mole of sodium dioxide reacts? So what you're going to get is the equation tells us when 2 moles react, so we just halve that. So when 1 mole reacts, it must be half the value. So the answer is 94 kilojoules of energy is released when 1 mole of sodium dioxide reacts in this equation. In the next question, we're going to look at the products. What happens when 6 moles of sulfur trioxide is formed? So sulfur trioxide is over here. So the equation tells us how much energy is released when 2 moles of sodium trioxide is released. So we can times, to get from 2 moles to 6 moles, we have to times by 3. So if we times 188 by 3, we get 564 kilojoules of energy is released. In this question, we're asked to calculate the heat energy released when 8 grams of oxygen reacts with sulfur dioxide. All right, so the oxygen is here, so we've got 1 mole in the equation. But we want to change that to grams because we've got 8 grams here. So we change 8 grams to moles. From the periodic table or from the question, we are given that the molar mass of oxygen gas, 2 atoms of oxygen, is 32 grams per mole. So we use this equation here, which you're given in the exam. So we say 8 grams divided by 32 grams per mole gives 0.25 or a quarter moles, right? So the equation tells us how much energy is released when 1 mole of oxygen gas reacts. So now we want to know how much reacts when a quarter of a mole reacts. So we can divide by 4 or times by 0.25 and we'll get 47 kilojoules of energy are released. So the equation told us that 1 mole releases 188 kilojoules, so a quarter of a mole releases a quarter of the energy. And now this question is asking about products being formed. So we've got 16 grams of sulfur trioxide. We know that we've given the molar mass. So we use our equation to change the 16 grams from mass, grams, to moles. So 16 divided by 80 gives us 0.2 moles. And we use the ratio from the chemical equation. So in the chemical equation, says that 2 moles, when 2 moles of sulfur trioxide are released, it means that 188 kilojoules are released. So when 0.2 moles is released, it's only 18.8 kilojoules is released. In this example, you are asked calculate the heat energy released when 24 grams, always look for the numbers, 24 grams of sulfur dioxide react with oxygen. So we can see that 2 moles react with oxygen to form 2 moles of sulfur trioxide, releases 188 kilojoules. So 24 grams. So we've got a mole ratio, we've got mass, we need to use our molar mass, which is here, 64 grams per mole, which is actually given in the question, or you can work it out from the periodic table, and then use the equation to change the grams, 24 grams, and divided by, so little m stands for grams for mass, big M stands for molar mass. So 24 divided by 64 equals 0.375 moles. So we're not going to round it yet or anything. We're going to use this equation, use this value, and we're going to use the ratio from the chemical equation to calculate the heat release. So the chemical equation tells us that 2 moles releases 188 kilojoules. So if we use that as a ratio, so we want 0.375 moles, what you can actually do is say 1 mole releases half of that and then times it by 0.375 and you get 35.3 kilojoules of release. And I've just rounded that to 3 significant figures. So in this video, we've used mole ratios or stoichiometry to calculate the amount of energy released or absorbed in a chemical reaction, e.g. per gram of reactant, or we could do per gram of a product.